Welcome, everybody. Thanks for attending one of the last sessions in Build 2013. It's a wonderful day out there, so I really appreciate you coming and joining for this last session. Somebody had put a bet on this session that no more than 10 people on the planet want to hear about virtual smart cards. So obviously they were wrong, and I wish I had taken the bet. Would have helped pay for some of the parking expenses in San Francisco City. My name is Himanshu Soni. I am a senior program manager in the Windows security team. In Windows security, we have a team called the Modern Authentication team. People who work in this team get paid to kill passwords. Our job is to kill passwords. I gave another talk on biometrics earlier. The session ID was 2-9110. You're welcome to look at this talk on channel 9. Today, we're going to talk about virtual smart cards and how they can be used in enterprise, BYOD, and consumer scenarios. So while you read the agenda slide, there's a funny story that I always tell. This is not about me, a friend of mine, not me. At Microsoft, every year we have to finish our self-assessments. That's how we get promoted. So there's usually a deadline. By that day, you have to check in your self-assessment. So this friend of mine he's a lazy person. He always waits till the last minute to check in his assessment. So one fine Friday evening, he finished his assessment, and he thought he'll just go home and do the final edits and then check it in. So he went home, got home, had dinner, put the kids to bed. Then he started working on his assessment to check it in, and then he realized that he forgot his smart card reader at home, at office. And we at Microsoft need two-factor auth. We need smart cards to do VPN into work. So he couldn't VPN in. So, it was sort of a bad situation. He had to check in his stuff. So he talked to his wife and said, I'll just go to my office real quick, get my smart card reader, come back home, and then, do my stuff, and then we can enjoy the weekend. So he quickly drove to the office, got into his office, found his smart card reader, and then, like most people, when you get into your office, you want to check your email real quick, to see if there's something important. So he opened up his laptop, and started doing some work, and then, next thing you know, 5 minutes became an hour, and then he got really late. Wife at home was really furious at him. By the time he got home, his wife was so mad at him that he had to sleep on the couch. So if you don't want your friends to sleep on the couch, not that it's a bad thing always, but in case you don't, listen to this talk very carefully. So what is two-factor auth? It's typically, two factors, something you have, like a smart card, an OTP device, and something like a PIN. You need two-factor auth because sometimes password's not good enough. While you read this slide, I don't have to this crowd, I don't have to tell how bad passwords are. Weak passwords are of course, can be guessed. Passwords can be used without the user's knowledge on other systems. We all know about the problem with passwords. The story that I told in the beginning sort of had a sad but not tragic ending. But in a lot of cases, when passwords get compromised, the impact could be serious. It could be a social impact, financial impact. The outcome could be a lot of stress for the user to outright dangerous in certain circumstances where you're guarding highly sensitive or highly secure information. So this is why you should look at using authentication techniques other than passwords. So two-factor authentication, for example, which is where you have a device or you have something and something where one factor protects the other, is important. It's better than passwords. And as we go along, you'll see more and more passwords getting compromised. We want to be in a world where passwords get diminished, their use gets diminished, and we have more convenient, more secure technologies that organizations can use to authenticate users. So in Windows 8, this is a Windows 8 slide, by the way. We didn't really talk about Windows 8, this feature in Windows 8 at a public conference or at a public setting. We introduced this thing called virtual smart cards in Windows 8. It uses the TPM module on the PC. So most enterprise laptops ship with TPM. A lot of connected standby devices, so the tablets or the always-on, always connected devices, ship with TPMs. In fact, it's a logo requirement now. So this feature uses the TPM on a PC and exposes the TPM as a smart card. So smart cards, as you know, have three important properties. One is that it can perform cryptographic operations on the card itself, not on the host OS's memory. and then it can generate non-exportable keys. So once the key is on the smart card, it cannot be taken out. And then there is this thing called the dictionary attack prevention logic, where if you enter the wrong pin many times, the card blocks itself, so nobody can use it. So for example, if you lost your smart card, unless the other person has your pin, they can't use the smart card to authenticate as you. So this TPM virtual smart card is exposed as a smart card to applications in the OS. So any application that knows how to talk to smart cards can talk to these devices. So the pin is what you know for this, and the device itself, the PC itself, is what you have. So that makes it a two-factor auth, the possession of the device. And it's important here. A lot of people ask, how is this two-factor? Because usually you have one device. It is two-factor when you're authenticated to a network resource. If you're authenticating to that PC itself, it's not really two-factor authentication. So that's a clear distinction here. We need to keep that in mind. So where can you use these virtual smart cards? So as I mentioned, you can use it for remote access using VPN or Microsoft Direct Access. I don't know how many of you here have used Microsoft Direct Access. We have it here at Microsoft, where when you log on to your PC, you log on with your smart card, and it connects you to your corporate directly without having to fire up VPN. Of course, you have VPN. So especially for BYOD, where users bring their own devices like the Surface RT, you can use virtual smart cards because people don't find it too convenient to connect physical smart cards to these devices. You can, of course, log on to a PC. The PC has to be domain joined. We don't yet support logging on to non-domain joined PC with smart cards. You can use virtual smart cards for SSL client authentication. So in a lot of enterprise, government to citizen, healthcare, banking scenarios, you can use virtual smart cards to authenticate the users using a two-factor auth mechanism. You don't have to distribute tokens to the users. The users have those devices that have TPMs, so you can use those as virtual smart cards to authenticate the user. You can do secure email, so you can sign email with virtual smart cards, just like any smart card, and you can also use virtual smart cards to decrypt email that was encrypted to the recipient. You can do document protection, so you can sign documents, decrypt documents, and there's BitLocker drive encryption. So this is sort of an interesting aspect of virtual smart cards, where you can protect a data volume with a virtual smart card such that it can only be decrypted on that device. So you can use that device for backing up data, but you can only decrypt it on that device, because the virtual smart cards are sort of like fixed smart cards, so they can't be taken out of that PC. So the device that you encrypt with that virtual smart card can only be decrypted on that device and nowhere else. So before we go deep into virtual smart cards, how you can manage them, how you can use them, I want to go over some key aspects of smart cards. So smart cards typically have a user-selected PIN. Sometimes it could be 4 digits. Some people are crazy. They have 128 characters. And these are typically user-selected. So and the idea behind smart card PINs is that they're supposed to be simple because there are two factors. So you don't have to deal with complexities of passwords. There's an admin key associated with smart cards. These are typically auto-generated and archived on some server somewhere. And these are used to reset the PIN if the user forgets the PIN or unblock the card. If you enter the PIN wrong too many times, the card gets blocked, and an admin key has to be used to unblock the card. And since this key is typically in control of the administrator or the issuer of the credential, the user has to call in or go through some additional proofing or additional authentication process to unblock the card. Some cards also use PUC, or the PIN unblock keys. We're not going to focus a lot on PUC in this talk. Cards also have a unique ID or card ID, serial number, and these are typically used for inventory management. So if you have a server-side inventory management, you can identify cards by card IDs. And of course, you can put certificates and private keys on the cards that you use to authenticate users or perform cryptographic operations. There are two types of deployments for virtual smart cards. There are the managed virtual smart cards and unmanaged virtual smart cards. I apologize for the checkbox, the green check marks, not in the right row. It's what I'll go over. So there is this inventory management aspect, which applies to manage virtual smart cards. This is where on the server side, you keep track of what user has what smart card. So as I mentioned in the previous slide, there's this concept of card ID. So on the server side, you keep track of what user got what card ID on what device. So that way you can identify the right card, the right admin key, and then perform operations on that card. For managed virtual smart cards, of course, you have to do inventory management. But for unmanaged virtual smart cards, which are sort of use and throw away, you can do without the inventory management. This is where you create a card on the PC, you put certs on it, but you don't worry about managing the card. So, and we'll go over this a little bit later in the details. You can do pin reset and unblock on managed virtual smart cards. So when the user forgets the pin, or if the user blocks the card, they can call an IT help desk or go through some other process and unblock the card. And you can do these on managed virtual smart cards, but on unmanaged virtual smart cards, because there is no inventory management, there is no mechanism to maintain those admin keys. If you block your card, or if you need to reset the pin, you have to pretty much throw away that card. And because this is a software card, this is a virtual smart card, you can throw away as many as you want and get a new one. You can also do pin change on these cards, and that can be done on both managed and unmanaged virtual smart cards. You can do policy enforcement, and that's by the virtue of doing inventory management. So for example, you can do things like one user gets one virtual smart card on one device. So that way you know how many smart cards are in circulation and how people are using them. And because there is no inventory management for unmanaged virtual smart cards, you don't get the policy enforcement on the unmanaged virtual smart card. And of course, you have the certificate issues and management of the certificates. So you issue certificates, you revoke them, you renew them when they expire, and that you have to do on both managed and unmanaged virtual smart cards. So these two types of smart cards come with their own deployment complexity. So managed virtual smart cards deployments are obviously more complex because there's more information you need to keep on the server side. So there's a server side virtual smart card management component that's required for managed virtual smart cards, but not for unmanaged virtual smart cards. You can have an app on a local PC that can just create a virtual smart card if it's unmanaged without having to talk to a server about it. Then you have policy enforcement modules like the ones that I mentioned. There is the one virtual smart card per user per device. There are other policies similar to those that you can apply on managed virtual smart cards, but not on unmanaged virtual smart cards. There's pin management. So by the virtue of being managed, you can manage the admin key of a virtual smart card, and by that you can do pin management. So you can reset the pin, unblock the card on managed virtual smart cards. On unmanaged virtual smart cards, because this option is not available, you pretty much throw away the card, delete it, and then create another one. Then you need a certificate server, and that's required on both sides because you need to issue certificates to these virtual smart cards. And then last but not the least, you need a browser plugin or a client app on the client PC to create these cards, to manage them on the client PC. So what's new in Windows 8.1? So what all the stuff I talked about before was all Windows 8. That's not new in Windows 8.1. So in Windows 8.1, we now can enable Windows Store apps to manage virtual smart cards. In Windows 8, this is a story from Microsoft. When we first deployed this technology, it was a pilot for 20 users, and all execs signed up for it. Like the top of the line people signed up for this, and I had to go visit a lot of these execs' offices to set up virtual smart cards on their machines. It was very difficult on Windows 8 to create these cards, and because there's a browser plugin involved, if you have a bug in IE or the browser plugin has a bug, it was very difficult to get these things working. In Windows 8.1, now you can write a store app, simple store app, that can manage virtual smart cards from creation to destruction. So we have new APIs in Windows 8.1, new WinRT APIs that you can use to manage virtual smart cards. Some of those APIs apply to physical smart cards as well, and we'll go over them in the next few slides. We also exposed pin policies for virtual smart card, and this is sort of an interesting aspect. We introduced these not to make life difficult for a user by allowing an admin to create complex policies that require complex pins. We introduced this so that admins can define simpler rules. So we had a customer that asked us for a way for them to dictate that the pins be simple. The reason for that was that people were, out of their just good nature, they were selecting complex pins, pins that were similar in complexity to their account passwords. And on touch devices, it's very difficult sometimes to enter a complex password. So people were selecting complex pins and entering them wrong and blocking their cards. And it was resulting in a loss of productivity, loss in revenue. So we were asked to introduce pin policies so they can define simpler policies. So this is sort of a interesting aspect to this. Of course, we allow you to still define complex policies if you want. If you want to hurt your users, you can always select a complex password policy, a pin policy. We also have new ways for certificate enrollment. I won't go into much details on that. There's a lot of information on those in our online documentation. And we have new ways, new APIs for using certificates for cryptographic operations. So in Windows 8, we can only do authentication or client authentication with certificates. But in Windows 8.1, there's more we can do. Can you repeat your question? So the question is, do we have an app to manage certificates, or is just the APIs? It's just the API. So you have to write the API, the apps yourself using those APIs to manage certificates. So here are some of the key features of smart card APIs. There's a lot of information on this deck, on this slide. So the namespace is windows.devices.smartcards. These are the WinRT APIs. And you require a shared user certificates capability, and depending upon the scenario, you may require enterprise authentication capability. With these APIs, some of these APIs apply to both physical smart cards and virtual smart cards. And I'll go through them one by one. So you can query smart card readers and see when the cards come in and out, and you can use those for both physical and virtual smart cards. You can list cards that are available in a smart card reader, retrieve their name, retrieve the card ID of the card. This could be very useful when you have more than one smart cards on a PC and you want to know which one is the one that your app is supposed to manage. And that you can use on both virtual and physical smart cards. When I say physical smart card, this is the card form factor, by the way. So I'm going to use that term quite a lot in this talk. So that's the card form factor. You can verify the admin key of a card if it's correct or not. Sometimes apps want to do that because if you have more than one smart cards on a system, in order to identify the right one, you may have to use the admin key to see if that's the right card that you're going to manage. It typically doesn't happen, but we have an API in case you have a situation where you have more than one smart card. You can provision or reformat a card with a given card ID. So this is where once you create a card, a blank card is not usable until you provision it or format it and give it a card ID. So you can use those for physical cards and virtual smart cards. We have APIs to change PIN by entering the old PIN and then specifying the new PIN. And that applies to both physical and virtual smart cards. And similarly, using the admin key, you can change an existing admin key, reset the PIN if the user has forgotten the PIN, or unblock a card using challenge response. So as I mentioned PUC before, we don't have support for PUC in Windows 8.1. So through the WinRT APIs, you have to use challenge response or the admin key. The last three aspects are only applicable to virtual smart cards. So you can create a virtual smart card on a PC using a WinRT API. You can delete a virtual smart card, and then you can specify PIN policies, and those only apply to virtual smart cards. We don't support PIN policy construct on physical smart cards because they have to be enforced by the card itself and not by the OS. So we'll go through a brief, quick lifecycle overview of a virtual smart card. So you start by creating a virtual smart card from scratch. So there's a TPM module on a PC, and it's auto-provisioned. You can create a virtual smart card. Then you go into the provision state where you personalize the card to the user. So you let the user select a PIN. You enroll the user for certificates on that card. That's when it becomes a provision card. And then the user uses the card. During the use of the card, the user may have to change the PIN or reset the PIN or unblock the card. You may also do certificate renewal on the card. And once you're done with the card, you delete the card. So that's sort of a quick life cycle of a virtual smart card. That's the life cycle it goes. So it's very similar to a physical smart card, except for the create part is done in a factory somewhere. So with a virtual smart card, that factory is your PC. So here's a sample flow. So this is a complex topic. So I wanted to give a simple overview of how a store app can manage a card lifecycle. There's a server-side component and there's a client-side component. And this is about a managed card, but I'll talk about the areas where an unmanaged card can come in. So you start, I don't know if you can read this, sorry for the small font here. There's a lot of information on this slide. So you start with the app creating a virtual smart card on the local machine with a default admin key or a key known to the server. So for example, in the case of a managed virtual smart card, this key could be something that the server sends to the client app itself, or it could be pre-known to the app, because the app is written specific to a server backend, so it could be pre-known. And the reason for that is so that the server can then later on issue commands to the client app to change the admin key. So you start with a known admin key and then you change it to a card-specific admin key. So that's what happens. So you receive keyword diversification information from the server, and then on the client side you act on it and then diversify the admin key or change the admin key and send an updated inventory to the server. So by this point, for a managed card, you have a card that has a diversified admin key that only applies to that card, and the server has some information, maybe not the admin key directly itself, but some algorithm maybe that can be used to regenerate that same admin key on the server. That's typically how it's done. The admin keys are never actually stored on the server. They're always regenerated using some known algorithm. In case of unmanaged virtual smart cards, in step 1 there, you would just create a virtual smart card with a random admin key and discard it. There is no server-side backup. So because the admin key is random and discarded, there's some stuff that you cannot do with that admin key later on. Once the card is created and provisioned, then you send a certificate request to the server with additional proofs, and I'll talk about those later on as well. And then the server then sends the client app back a certificate that you install. So at this point, the virtual smart card is ready for use. You have a smart card that has a PIN and that has a certificate and a private key on it that the user can use to authenticate or perform cryptographic operations. And then the user uses the card, you do PIN management, change PIN, reset PIN, unblock the card, you do certificate management like certificate renewal, certificate revocation. So that's it's sort of a bad graphic here, but that depicts back and forth between the client and the server to use the card. And once you're done with the card, you delete the card. Let's say, for example, the user is no longer an employee of a company or no longer needs that credential, you can delete the card. So that's sort of a sample flow of an app. Most apps won't be as simple as this, but this gives you an overall idea of how a client app can manage a life cycle of a virtual smart card with the server-side backend. So now I'm going to go through some of these APIs. I'm going to present a very simplified view of these APIs because if I start going through each and every API that we've exposed, we're going to be here for a much longer time than we originally scheduled for. But this will give you an idea of how to write that sample app, or how to design your apps, or how to go about writing a client and a server piece for managing virtual smart cards. So the key class here is the smart card provisioning class. And these are all WinRT APIs, by the way. These are not Win32 APIs. And the key method here is request virtual smart card creation. So to that API, you can pass a friendly name, an admin key, a GUID for card ID, and I believe there's an override available without the card ID, and a PIN policy. And I think there's an override without the PIN policy as well, so in which case we'll use a default PIN policy, and I'll talk about that later. So with this API, you can create a virtual smart card on a local PC if there's a TPM on the machine. So here's a code snippet. Again, I apologize for the small font. This should be a recorded session, so later on you can go through this. But the key steps here are, we start with the known admin key, so in this case it's 24 bytes. And then you create a new smart card PIN policy object, and you specify the attributes of the PIN policy. So in this case, we have a minimum length of 8, and we are allowing lowercase letters. So the PIN policies have this notion of allow, disallow, or request at least 1. So in this case, we have a minimum length of 8. We allow for lowercase letters. We require at least 1 uppercase letter. We allow digits, and we disallow special characters. This is just an example. Again, the idea behind this feature is so that the pins don't have to have policies, or pins don't need to be complex. So you can imagine a simpler PIN policy where you have a minimum length of 4, for example, and that'd be the only PIN policy. So your users would have a 4-digit PIN, for example. Once you create your smart card PIN policy object, then you call this API request virtual smart card async, and you pass it a title for the or a friendly name for the virtual smart card, and this is what the user would see in device manager or in the devices page in modern settings. And you pass in the admin key, the PIN policy, and the card ID, which is the GUID, and you get the return code. So this is a very simplified snippet. This is how you would go about creating a virtual smart card on a local PC. So a bit more about PIN policies. So this is an input to create API, and it's enforced throughout the lifecycle of that card. So every time you change the PIN or unblock the card, the PIN policy is applied. You don't get to re-specify the PIN policy after the card is created. So it's sort of minted onto the virtual smart card. So there is a minimum length aspect in Windows 8.1. That length could be a minimum 4, and we allow for a maximum length of 128. I hope nobody uses that long of a PIN, but we allow it. We allow uppercase, lowercase, digits, and special characters. The default PIN policy, if you don't specify any PIN policy in your card creation, is always 8 characters minimum, and that's same as Windows. So if you don't specify a PIN policy, the card has the same policy as Windows 8. And the pins have to be in the printable ASCII key range. Yeah. So can you repeat the question? The question is, do we have any policy for alphanumeric? So you have to use these to define the alphanumeric PIN policy. So give me an example of an alphanumeric PIN, and maybe after the meeting, after the talk, I can give you some ways of defining it. So once the card is created, you have to, virtual smart cards get provisioned. When you create them, they get provisioned. But if it's a physical smart card, like the form factor that comes in a plastic, you typically have to provision them. You have to format the card before you can put certificates on them. So we have this method called getChallengeContext async on the smart card provisioning class, and we have methods called provision async and change admin key async on the smart card challenge context class, and I'll show you in the next slides how to use them. So these APIs are used to format the card, change the admin key of the card, and format the card for use. So here's a code snippet for changing the admin key of the card. So you start with the smart card object. There's a subsequent slide that talks about how do you find that smart card, because you could have multiple smart cards on a PC. But for now, just assume that you have a smart card. So you start with a smart card, and you get a smart card provisioning object out of it. And then you call this function called getChallengeContext async on the card provision. This is challenge response based. So basically, you start. The getChallengeContext async gives you a challenge. It's some sequence of characters that you get, and then typically you have to send them to a server to get a response. But if you're starting with a known admin key, you can create the response locally. So the response is pretty much an encrypted blob of the challenge, so that the server or some process on the client PC creates an encrypted blob out of the challenge, sends it to the card, and because the card has the admin key, it can decrypt it. And once it successfully decrypts it, it knows that the other side has the admin key. So that's how you do the authentication of the admin key. So once you have, and because changing an admin key is an administrative operation, you have to authenticate as admin. So once you have received the right response, you call the change administrative key async API, and you pass the response. Response is the encrypted blob of the challenge, and you pass the new admin key. So that's how you change the admin key on a smart card. And this applies to both virtual and physical smart cards. So once you change the admin key, then you can call the APIs to provision or format the card. So you do the challenge response dance with the server. You start with the challenge from the card. You get a challenge, and in this case, the function name is called calculate response. This is just for demonstration. This is just for the slide. This is not really, you're not really calculating a response on the client. Typically, you would send that challenge to a server, and the server may ask additional information from the client. In some cases, it could be that you block the user and you ask the user to call help desk, and the user reads the challenge to the help desk and then get a response back after the help desk person asks for a few identifying information, like what is your mother's maiden name, or what is your social security number, or anything like that, to get the response from the help desk person. And then you provide the response back, pass it to the provision async API to format the card. So at this point, the card is ready to put certificates on them. If I'm going too fast, please feel free to interrupt me in the middle. This is a complex topic, and I want to make sure that we get the message across. So once you have a smart card that is ready to go, you have to put certificates on them. In the case of virtual smart cards, there is this concept of additional proofs when you put certificates on a smart card. If you use a username and password as the means of identifying and authenticating a user, then you're starting with a weak credential to get the user a strong credential. So the strong credential in that case is as weak as the weak credential. So it doesn't work in most cases, but in some deployments it may be an option. So in this, you see the domain username and password, or a username and password could be good enough to identify and authenticate the user to get a virtual smart card certificate. Then you can also do challenge questions. So in your app, for example, before you send a certificate request to the server, you can ask the user for a few challenge questions. The server can send you the challenge questions. You get the responses from the user, and then you send them to the server. The server verifies the answers, and then if the server is satisfied that the answers are right, it can then issue the certificate to the client PC. You can also have an OTP-based additional proof where when the user is requesting a certificate, the server side sends an OTP message back to the user. So, for example, I'm going to show that in my demo as well. For example, let's say somebody else was trying to enroll for a virtual smart card using my credentials, and somehow they knew my username and password, and then they did that. With the OTP-based approach, because the message is going to come to my cell phone, the other person, unless he has my cell phone, he won't be able to complete the authentication process and get a smart card or get a smart card certificate. There is this other method of using corpnet connection with the username and password. So if the user is inside a corpnet, maybe let's say connected to the wired network, you can use a username and password. So the user is inside the building, he must have entered it using a physical access card. And in those cases, for some deployments, using a username and password may be sufficient. Of course, you can sign the request with a physical smart card. This is how we have it here at Microsoft, where anybody at Microsoft who gets a virtual smart card, they have to sign the request with their corporate badge, because our corporate badges are also smart cards. So that's one of the strongest ways of getting a virtual smart card. So you derive a credential out of an existing credential, and that has a cryptographic binding between the new credential and the old credential, because the request is signed with the physical smart card. And because the physical smart card was likely issued by the user going into an IT help desk, where somebody's checking the license photo or making sure that the user is the right user, you can then derive that same derive a virtual smart card credential out of that. So you basically derive the trust out of a strong credential. And of course, last but not least, you can have users go visit an IT office or a kiosk. It is not very practical for large deployments. You don't want people standing up in lines inside of an IT help desk or an IT office or a kiosk with their laptops in their hands getting virtual smart cards. But it's an option for small deployments where somebody, maybe the IT guy, visits your office and then helps you set up virtual smart card. So these are some of the ways where you can have additional proofs when you do certificate enrollment. It's an important aspect. You should always consider what's at risk, what are the security requirements, and then appropriately pick one. Maybe there are more options, more ways to do additional proofing, but these are just a sample list. So here are some certificate enrollment APIs. So you have two classes here, certificate request properties and certificate enrollment manager. And the methods are certificate request async and install certificate async. I'll show you a quick code snippet. Again, apologize for the small font. I think these slides get shared as well, so you can always look at the slides. Here, what we are doing is, the font size is small because I want to show everything in one slide. You start with creating a virtual smart card. For example, in this case, we call the request virtual smart card creation async API to create a virtual smart card. Then on the client PC, we create a certificate request. You set some attributes, so you specify a subject name, key size. The key storage provider for this request is the smart card key storage provider. and you specify a reader name, and you get the reader name from the card provision object that you get when you create the card. So that ensures that the key is created on the smart card that you have just created. Then you call this API on the certificate enrollment manager class called the create request async API, and you pass the request properties object. And then once you have the request, you can send it to an HTTP server. This is some example here. And you would typically embed additional proofs here. So if it's an OTP-based additional proof, you would embed that in the request and send it to the server. If it's something like signing the request with an existing certificate, then before you send the request to the server, you would sign the request, and we have additional APIs for those as well. So once you send the request over HTTP to the server and get a response back, then you basically call the install certificate async API and install the certificate onto the smart card. And because the request was created on the smart card, the certificate also gets stored on the smart card itself. So this is how you can simply write a quick sample on how card can be created and certificates can be installed on the card. So I talked a lot about using the smart card object, but how do you get that object? How do you find that object? So we have these two classes, smart card reader and smart card provisioning, and we have these methods called get device selector and get ID async. And I'll show you a quick code snippet on how to get the card object. So whenever you're looking for a card, you have to start with something known. So in most cases, you would know the card ID. So if your app created that card, you can store that card ID somewhere in the app data itself, and you can then use that later on to find the right card. So in this case, in this code snippet, for example, you start with a known target card ID, and then you get a selector out of the smart card reader. So you get a selector for smart card readers by using the get device selector API, and then you get a device enumerator from that. So you pass a selector and then you get a device enumerator. So that device enumerator has all the smart card readers on the PC. Most PCs would have only one smart card reader, but in case you have more than one smart card readers, you will get an enumeration here. And then you iterate through each of these devices, and you get a smart card reader from each device, and then you get smart cards inserted into those readers. So in the case of virtual smart cards, they're always inserted, but in case of physical smart cards, they may or may not be. But you get cards. Right now, we only support one smart card per reader. So if it's a multi-slot reader, they have to enumerate as two different readers. But this API is future-proof. So in future, if we do expose the aspect of multiple cards in a single reader, then you would have an enumeration of cards, and you iterate through each card and then see if that's the right card for you or not. So in this case, we'll go through the cards enumeration, and we'll look at each card. So we start with a card provision object, and then we get its ID by calling the get ID async API, and then we compare that with the one that is passed in. So in the case the app stored that card ID, you would compare it, and if it matches, then that's the card you want. And if you don't find the right card, then you keep looking. So that's how you locate a card on a given system from scratch. You have to start with something known. You have to know the card. You either store the card ID locally on the app, or the app can also retrieve that from a server. So maybe because the server may be keeping the inventories, in case of managed virtual smart cards, server keeps the inventory, so you could query that information from the server, get the card ID, and then find the right card on the PC. So that's how you get a card object, and this is what you pass around in all those APIs to do operations on the card. So how do you change PIN on a smart card? Real simple, request PIN change async API on a smart card provisioning class. So you start with a smart card object. So you use the locate card way of finding the right card. You get a card provision object out of it, and then you call this request PIN change async API. And we draw the UX. You don't have to draw the UX for collecting the old PIN and entering the new PIN. Windows will draw that UX, collect the PIN, and pass it to the card. So your app never gets to handle the PIN itself. So this is how you can quickly change the PIN on a virtual smart card. So for changing the PIN, you need to know the old PIN, of course, and then enter the new PIN. In the case of virtual smart cards, if there was a PIN policy specified during card creation, that PIN policy is applied during PIN change as well. So user cannot violate that policy after the card is created. And this is an API that you can use to reset the PIN or unblock the card. So if the user has forgotten the PIN or has blocked the card, then you can use the request PIN reset async API to unblock the card. And it is sort of an interesting pattern here. Again, apologize for the small font. When you're unblocking a card, because the user doesn't know the PIN, you have to authenticate as an admin on the card. So there is a challenge response dance that you have to do with the server. So here, this is we're using a deferral pattern here. So you start with a card object, and you get its card ID. Then you call this API request pin reset async API, and then you go to this deferral pattern where your app needs to somehow get the response from the server. So you can get the challenge from the request itself, and then you see that API, the retrieve response for challenge from server, that's just a name. You can have any name you want. This is where you would do the bulk of the processing. This is where you would either prompt the user to call the help desk and get a response for a challenge by showing the challenge first to the user, or you could automatically retrieve it by asking the user some questions. And then once you get the response back, then on the request you have to set the response. So that's the deferral pattern. So you call the request pin reset async API, and then your app has to set the response on the request. And how you get that response from the server is it depends on how the deployment has chosen to do so. In some cases, as I said, it could be just you retrieve the response from the server, and in some cases it could be that the user has to call in the help desk or answer additional questions. And once you have the response, you complete the deferral, and that completes the process. So when you do a pin reset, you've done now an admin key-based challenge response by authenticating as admin to the card. And then in this process, when we conclude it, Windows draws the UX to collect the new PIN and confirm PIN, and then the PIN is changed on the card. So user specifies the PIN, and the PIN is set on the card. So this is how you would unblock a card. I want to mention something here that I forgot earlier. In the case of virtual smart cards, I don't know how many of you know about this, but the dictionary attack prevention or the anti-hammering is very TPM dependent. And a lot of TPMs have varying anti-hammerings, to put it lightly. Some TPMs behave much differently than others. And so we realized very quickly in Windows 8 that was not going to work for large deployments. It's a pain telling a user that they have to wait. Most TPMs go into this delay lock, where if you enter the PIN wrong n number of times, where n depends on the TPM manufacturer, it goes into a delay of from several seconds to several minutes. And then some TPMs over time forget the bad period time. So it basically it's called leakage or recovery. So after a few days, it'll go back to not remembering that somebody entered the wrong PIN. So it was very TPM manufacturer dependent and very hard to explain to a user on why the user is not able to use his virtual smart card. So in Windows 8.1, we decided to put an additional layer in front of the TPM. So now in Windows 8.1, after the user enters the wrong PIN 5 times, and that's a magic number 5, we don't let you configure it, we will block the card. It doesn't mean that the TPM is blocked. We'll just block the card, and the user then has to do this challenge response based go through this challenge response based flow to unblock the card. It does two things. It tells the user to be very careful with the PIN, and it buys time, because as I said, most TPMs have this concept of leakage or recovery where they over time forget wrong PINs. So by blocking the user after 5 attempts, we make the user conscious. So fat fingers or casual users, they're more careful in their subsequent attempts, and also it buys time for the TPM to recover itself. And in all this, we always hit the TPM. So even though we block the user at the 5th attempt, each one of those attempts does hit the TPM. So it does count against the TPM's anti-hammering logic. So we don't reduce the security. It's just more of a usability feature where we give a consistent experience to user across all TPMs, and we give a consistent experience across on the recovering aspect of it. So the question is, does it conflict? Yes. Yeah, so if I understand your question, you're asking if it conflicts with the TBS's anti-hammering. So that applies to standard user, and virtual smart card doesn't go through that route. So we directly hit the TPM. So it is a similar notion, but it's not tied to that component itself. So you can say it's an extension of that. The intent is the same, to prevent the user from causing self-damage, basically. And so once you're done with your virtual smart card, let's say the employee is leaving the company, or if it's a BYOD device, the employee is selling the device on Craigslist or eBay, and you don't want that card sitting on that PC. The employee can then use your app to delete a virtual smart card. So you can call this request virtual smart card deletion async API to delete the virtual smart card. And when you do this, all key material on the device is deleted, zeroized. We also have a UI, built-in UI to delete virtual smart cards. So if you go to the modern devices settings page, you can select a virtual smart card by identifying it by its name and delete it. So there are two ways of deleting virtual smart cards. So the question is, if you reinstall Windows, does the virtual smart card survive or not? So on a reinstall, the virtual smart card does not survive. The TPM maintains its state, but the virtual smart card is lost. If you did an upgrade, then virtual smart card is preserved across upgrades. Can you repeat the question?
Is there any way to take a virtual smart card and hold it in a physical token temporarily or transport it?
No. So the question is there a way to export contents out of a virtual smart card and hold them temporarily on a physical token or a physical smart card? And the answer is no. We don't allow exporting keys. It is one of the principles of the smart card. You cannot export keys out of a smart card. No. Yes. So from a virtual smart card, we don't allow you to export keys. You can import keys onto the cards. So you can start with a key on a token and then import them onto the card, but not the other way around. So this is showing you how you can simply delete a card. So because you can have multiple types of cards on a system, some physical, some virtual, we have this attribute called the kind, which tells you whether it's a TPM smart card or not. So if it's not a TPM smart card, the delete operation doesn't make sense on it. You cannot delete a physical smart card, not in this century. But on a virtual smart card, you can call the request virtual smart card deletion async API and delete the card. The user running that app has to be administrator on the box. A standard user cannot delete smart cards. Similarly, for create, the user has to be an admin. You cannot have standard users create or delete cards. Because if we allowed that, then you could have standard user malware that can go and delete cards or create cards and exhaust the system of its limits. It is through a store app. We have a broker that elevates, but the user that is logged on has to be admin on the box. So the question, just to repeat, the question was, because of this requirement of the user being admin, can the store app create and delete cards? And the answer is yes. We have a broker that does that. There's a special broker for that. So now putting it all together, so I'm going to show you a sample app that creates a virtual smart card. So on this device, this is a Surface RT device, an ARM device. So nothing but store app is running on this device that I'm going to use to create a virtual smart card. So this icon here that looks like an open lock is a fancy icon that my team built for this demo. So here's the simple app. It has a few options. You can create a virtual smart card, you can change the smart card pin, you can remove virtual smart card or delete it. You can have many more options here. we're going to go through the create flow, which is where we're going to start from scratch and create a virtual smart card on a PC. And this is all happening locally on this PC. So I'll click on the create button. So it's going to ask me, so as I mentioned before, additional proof. So it's going to first ask me to identify myself. So I'm going to use my domain credentials to tell the app who I am, so it can put the right certificate and it can request the right certificate for me. So I'm going to use my corporate credentials. Sort of a long password. And I'm using a keyboard, so it's easy for me to type, but if it was a touch-only device, it would be difficult. So at this point, it's creating a card, and it's going to ask me to set a PIN on the card. So as a user, I can select a simple PIN, 4 digits, or a complex PIN, and I can also look at what policies are being enforced here. So in this case, it says that the PIN has to be minimum 8 characters, maximum 127, and then you can see the other policies that are applicable here. So the user can click on it to see why a PIN is being rejected or being denied. So I'm going to use a simple PIN. I always use simple PINs. You can see 1, 2, 3, 4, 5, 6, 7, 8, and that's the idea. That's not the PIN for this device, by the way. So I enter the PIN, I enter the confirm PIN, so if they match. So this step takes a while. This is where we are querying the status of the TPM to see if it's provisioned or not. Once we see that the TPM is ready for use, we create a virtual smart card. So in that, we actually create device nodes. We create a smart card reader device node and a smart card device, and we create all the key hierarchy. And in this case also, because we require additional proof, so in this demo, there is an OTP dance that's going to happen. So the server side is going to send me an OTP message on my cell phone that I have to enter once the card is done creating, that I have to enter to get the certificate. So that's the additional proof. So if somebody else was running this demo and did not have my cell phone, the process won't go through. Just wait for it a few more seconds. While you can enjoy, I'm sure this is somewhere in California, this lady is sitting and creating a virtual smart card on a device.
So it is also exposed to Win32 desktop apps?
Yes, so the question is it also exposed to Win32 desktop apps? And the answer is yes. The Win32 APIs for this were available in Windows 8 actually. In Windows 8.1, we enabled WinRT APIs. But a rich set of APIs are also exposed for Win32. So you can write your desktop apps or your browser plugins like ActiveX controls to manage virtual smart cards using Win32 APIs. But our hope is that with the store apps, you would be able to write with the WinRT APIs. You can write store apps to manage virtual smart cards. So it's done creating a virtual smart card. Now it's asking me to enter an OTP. So I'll check my phone where it's supposed to send the OTP message. So this concludes the round trip with the server. So the server, once I click continue, the server would know that the message was delivered to my phone and not somebody else, and it can then issue a certificate. So at this point, I have a virtual smart card on this PC that has a certificate on it that I can use to authenticate. So the next part of my demo, so we've created a virtual smart card. I'm going to show you some uses of it. So I'm going to show you 2 use cases. One is connecting to a remote to CorpNet. Using this new feature in Windows 8.1 called App Triggered VPN. This is where you can have certain apps that can be configured so that when the user launches those apps, VPN, the user is prompted to connect the VPN. So if the user hasn't established a connection before, the app can cause a trigger to appear, and then the user can then connect through VPN. So going back to my demo machine, Before this demo, I've configured the remote desktop app as an example app. Probably a bad example, but any app, any line of business app, any app can be configured to trigger remote to trigger VPN connection. So I'm going to run the remote desktop app. So as you can see, I get a toast notification that it says the app needs me to connect my corporate VPN. So when I click on it, it says corporate VPN action needed. When I click on it, it says we need your sign-in info to connect. And I continue, and it's going to then prompt me for my virtual smart card PIN. This is the smart card that I created in my previous demo. So at this point, if I enter my PIN, the VPN connection would be established, and the app can continue. So something went wrong in the demo. But the idea is that once the PIN is entered, the VPN connection is established, and then the app can then continue. So if I'm connecting through remote desktop app, for example, if I'm connecting to my work machine, it would establish a connection and ask me for my work machine username and password. So that's one demo. The other demo is, this is a demo of using a certificate on the virtual smart card to authenticate to a SharePoint in the public domain. So you can use SSL client authentication to authenticate a user to a public site. So there is this website. There is this company called Identity that have put together a demo that shows using certificates to authenticate users. So I'm going to use a virtual smart card certificate. So I've already established a relationship with that service. So I'm going to enter, go to that site. So this site, the Identity can use different identity providers. So you can use Google, Facebook, PayPal. But the Identity one, that's the one that's more interesting. They have configured over 2,000 CAs, so you can use any certificate to basically link to your profile on the SharePoint and authenticate the user. So I'm going to click on that link. And so it's going to ask me to select the certificate. So this is the certificate. So I've pre-linked my certificate with that site. So I can then select the certificate and enter my smart card PIN and authenticate to the website. So hopefully this part of the demo would work. If not, I apologize. Demo gods are not with us in this room today. The previous demo also went through some hiccups. So now it looked like it worked. So this site could, ask for my consent to use my information, and then it's going to take me to the main page on SharePoint. So this is where basically what I've done here is used SSL client authentication using a certificate on my virtual smart card to connect to a SharePoint site. And so if anybody was using password, they won't be able to go to this. So this is another demo of using a virtual smart card. So this could be a banking site, this could be a government to citizen, anything that uses SSL client authentication could leverage a similar approach. So you've seen the two demos. One of them didn't really work well. I don't know what happened, but we recovered in the second demo. So to summarize the key takeaways, so Windows 8.1 makes it super easy for store apps to manage virtual smart cards and physical smart cards. So you can use APIs to create all the way from creation to deletion of virtual smart cards, and you can also use some of those APIs to manage physical smart cards. We also went through some of the scenarios, some of the use cases for strong auth. including enterprise authentication, BYOD. I also showed you a demo of a consumer scenario, and it could be a bank site, it could be a healthcare, it could be anything that uses certificates. You also learned about what virtual smart cards are, although this was not a new feature in Windows 8.1. I think it was important for us to talk about virtual smart cards and what scenarios they enable. Here are some resources for you. I think this is a recorded session, so you don't have to write this down. These would be made available to you, so you can go and look at the virtual smart card white paper. There are some links for WinRT APIs WinRT APIs for smart cards and certificates, and there are links to samples. So the samples that are on these links may be slightly different from what I showed you. These were done to highlight the concept, highlight the usage pattern. So the samples that you see there may be slightly different. So we highly regard your feedback. So you attend this session. If you have any feedback for us, please scan this QR code and give us your feedback. We use your feedback to improve our messaging, improve the way we present these ideas, and also see if we are selecting the right sessions, the right information, the right technology in these conferences. We can take questions. I think we have time. Do we have time? Yes. So you have any questions? Yes. So the question is, can we expect these APIs to be available on the phone? I cannot answer that question. I don't work for the phone team, but we can talk offline and try to connect you with some of the phone people and ask them those questions directly. So the question is, are we going to expose lower level PCSE APIs in WinRT? So right now there is no plan for do that in Windows 8.1. If there is any use cases or any deployments that are blocked because of this, please let me know after the call and we can talk about. Can you repeat the question? Take the mic. Sorry, this.
He asked for Windows RT, right? But I'm asking for Win32. Do we have Win32 PCSE?
Yes, Win32 PCSE. So the question is, do we have Win32 PCSE APIs? We had, and?
For virtual smart cards.
For virtual smart cards. So virtual smart cards are smart cards for all intents and purposes. So the existing set of PCSE APIs that we have apply to virtual smart cards also. And those API sets have been in Windows since, I don't know, late 90s. Yes. Any more questions? So the question is, can I use public CAs for certificate enrollment? And the answer is yes. So in the app itself, you saw we were sending the request to an HTTP server. That could be any CA. It could be a Microsoft CA or a Keyon CA or Red Hat CMS. Any. It does not need Microsoft CA. It could be any CA. Pardon me? Yeah. So the request is sent to an intermediate server that can proxy. Yeah. So the question is, do we use SCEP protocol for the certificates? So through WinRT APIs, as I showed, it's just a simple. You create a request. You get a request. Literally, it's a blob. It's a base 64 encoded request that you have to send to an HTTP server. But on our desktop side, we do have support for SCEP in our APIs to do the certificate enrollment. It's from the client app to the server. So the question is, on the server side, where you typically have something like SCEP to communicate with the client apps, in this case, do you have to do something proprietary? So you have to put an HTTP server in the in the middle, because the client app itself, the WinRT app or the store app, does not know SCEP. So you have to put that intermediate HTTP server that understands SCEP on the back end and translate that to an HTTP message with the response in the response parameters to the client app. So you have to build that middle server.
So do you document the message format?
I believe so. The question is, do we document the message format? It's up to you. So as I said, the app simply gets a request and sends it an HTTP post message to the server.
So you're generating a blob and you're expecting a blob coming back.
Yeah, and that blob is certificate, X59 certificate. Yeah, that's all it is. We don't dictate the protocol. You could phone in. You can send that over email if you want. We don't come in the middle. It's up to you. It's how you've deployed your server, and how you do that exchange. It's a standard certificate request. So the question is, are we going to expose these APIs in .NET? So I don't know the answer off the top. I can take that question and have somebody from the PKI team connect with you. I don't own that set of APIs in Windows, unfortunately. So yeah. So the question is, are there any underlying changes in 8.1 and 8 for virtual smart cards that are going to impact things like performance and usability? So the only user visible change is where we block the card after 5 attempts. This was not possible in Windows 8. So in Windows 8.1, we tried to create an artificial bar so that all users across all TPMs get a consistent experience. Other than that, there is no visible UX change. We have the pin policy construct in Windows 8.1, but the default is the same pin policy as Windows 8, which is just the length. So other than that, performance and all other aspects stay the same. It largely depends on the TPM. So in this case, you saw it taking a bit longer, and that's likely because maybe the demo machine was not happy with me or the TPM was not working well. But it's all TPM. So we didn't do anything to improve or degrade the performance in that aspect. There's a limit of 10 virtual smart cards. There's a limit of 10 smart cards on a PC. Basically, if you have 10 cards connected to a PC, whether they're virtual or physical or combined, if you connect the 11th card, Windows will not talk to it. So no, there's no change in the size or the limits. There's no virtual smart. You're limited by the space on the disk itself. You can create 30. So there's the question is, what's the there is a limit on the number of certificates you can put on a smart card, and then there's a limit on number of smart cards you can have. So on virtual smart cards, you can have 30 certificates on a single card. So if you can have 10 smart cards on a PC, you have 300 certificates. I think it's more than anybody would ever need, hopefully. But those are the limits. There's no change in that. Okay. If there are no more questions, thank you again for attending. Enjoy the rest of the day. It's a beautiful day out there, and get some tan. Thank you.